Okay, we're going to be looking at the next section of the quiz here. We're looking at learning targets 13.6, 0.7, and 0.8 on this one. And learning target 13.6 really talks about molarity equation and solving it for a missing variable. This particular question is asking us to determine the molarity of a solution when we have 48.9 grams of NaCl dissolved in enough water to make 1.25 liters of solution. So the way that we're going to do this is two steps. The first step is we're going to convert mass to moles, and then we're going to use the molarity formula to go ahead and solve for molarity. So in step one, we are going to convert mass to moles. And in order to do that, we need to calculate the molar mass, but we're going to start by taking our given, which in this case is 48.9 grams of NaCl, and put it over 1, and we're going to go to moles. So we're going to calculate our molar mass. We have 1 Na, and if we go take a look at our periodic table, we see that sodium here has a molar mass of 22.99 grams. So I'm going to go record that times 22.99 grams. And chlorine, there's one of them, and we're going to go check that out on our periodic table. And chlorine has a mass of 35.45. So I'm going to record that. And we're going to add that up, so 22.99. That's not right. I multiplied instead of added. Is 58.44. So that's going to be 58.44 grams in 1 mole of NaCl. So I'm going to take the 1 mole of NaCl and put it over the 58.44 grams of NaCl. And at this point, my unit for grams has canceled out, and I'm left with moles. So the number of moles here is going to be, let's see, so we had 48.9 divided by 58.44. And I get something like 0.836755 . Okay, so that's moles of NaCl. Next, we're going to use the molarity equation. So solve for molarity using molarity is equal to moles over liters. So I'm going to use that formula. So molarity is equal to moles over liters. So that's my formula. I'm going to substitute in the number of moles, which is the 0.836755, and that's moles of NaCl. And the problem said that we were making about 1.25 liters. So now we're just going to take that and divide. And we get a molarity here somewhere in the ballpark of 0.669405175. But this problem has 3 significant figures all the way through. So I'm going to count my 3 sig figs. So 1, 2, 3. That 4 does not round that 9 up. So my final answer here is going to be 0.669 big mole molar NaCl. The next thing that I'm going to do is look at my dilution equation. And my dilution equation is M1V1 equals M2V2. So I'm going to go ahead and identify those variables here. So it says, what is the volume of 0.2 molar, or I'm sorry, of 2 molar KOH that is needed to prepare 150 milliliters of 0.5 molar or of 0.5 molar solution. So I'm going to go ahead and try to identify which is which. And it says, what volume of 2 molar KOH? The fact that my molarity here is huge and my molarity here is small, and dilution, and by virtue of what dilution means, it means that we are going to add water to a more concentrated solution. That means that the 2 molar in this case is going to be M1, and I'm going to be solving for how much of that do I need. My M2 is going to be 0.500 molar, and my V2 is going to be 150 milliliters. So my formula is already up above, but it's M1 V1, V1 equals M2 V2. So I'm just going to substitute in the things that I know. So in this particular problem, I know that M1 is 2.00 molar, and V1 is what I'm solving for. I have M2, which is 0.500 molar, and my volume, my V2 that I'm going to make, is about 150 milliliters. I'm going to combine what I can, so 0.5 times 150 is about 75. So that tells me that I'm going to have 2 molar times V1 equals, we'll say 75, and my unit here is going to be molarity times milliliters. I'm going to divide both sides by the 2 molar. And so my unit for molarity cancels out, and I'll be left with milliliters. So 75 divided by 2 gives me 37.5 volume. So I'm going to need, so that means that V1 is going to be 37.5 milliliters. And hopefully that makes a little bit of sense, because I shouldn't need a huge volume of a really concentrated solution when I'm diluting something. So that's going to be 37.5 milliliters, which will be my final answer. And then the last part of this particular video is about 13.8, which is predicting the products and then using your solubility rules to predict the states of matter. So what we've been doing in the past is we've been using the double replacement generic formula, which is X plus BY makes AY and BX. And so the first thing that we've always been doing is we've been matching our ions up. So under A, I'm going to put the potassium ion, and under X, I'm going to put the Cl ion, and under Y, I'm going to put the NO3 polyatomic ion, and under B, I'm going to put the Ag silver ion. Oops. The next thing that I really need to do is identify the charges of both of these, of all 4 of these ions, and crisscross them down. So potassium and nitrate, we'll take a look at those first. So I'm going to go to my periodic table, and I'm going to look and see that potassium is in the first column. Let's do this real quick. So this is +1, +2, +3, -3, -3, -2, -1. This is always a +2, this is always a +2, and this is always a +1. Really important stuff to know. So I kind of forgot what I'm doing here. Oh yeah, we're going to start with potassium. So potassium is in the first column, so it's a +1. And if I go down here, I hear nitrate, NO3, is a -1. Look at that. So in this case, I have a +1. Oops. I have a +1, and nitrate is a -1. I'm going to crisscross those charges down, like so. And I'm going to get K1NO31. So I don't really need any subscripts in my original problem. Silver, on the other hand, we're going to take a look at that one. If we hop over here, silver has a charge of a +1, and I believe it's paired up with chlorine. Chlorine has a charge of a -1. Okay, that's good. So this is going to tell me that Ag is a +1 and Cl is a -1. We're going to crisscross those charges down, and that becomes Ag1, Cl1. So we don't really have to add anything to that there either. So that's positive, I guess, in terms of making our lives easier. All right, so we now have our correct compounds written. The next thing we have to do is we have to go ahead and use our solubility rules to identify the states of matter. So with the first compound, we have potassium, right? And our solubility rules tell us things like group 1 metals, right? So group 1 metals, as you might recall from your work with them during the lab, was that anything with a group 1 metal is going to be anything in the first column. So these are going to be your lithiums, your sodiums, your potassiums, your rubidiums, your cesiums, and your franciums. Okay, so anything that's a group 1 metal will fall into that category. Now, if I go back here and I look at this and I say I've got potassium, right? So I'm going to go ahead and look at this and say salt, rule number 1 says salts with ammonium NH4 and group 1 are always soluble. So that means that because potassium is present here, that means that this first substance here, KNO3, is going to be aqueous. And then I'm going to skip over and look at and that's going to be because of rule number 1. And then I'm going to skip over and look at AgCl. So I'm going to look at the rules for AgCl. So Ag is not a group 1 metal, so rule number 1 doesn't apply. Chlorine is in rule number 2, and it says they're soluble except if they're paired up with silver, mercury, or lead. In this case, AgCl is definitely paired up with silver, so that means that this is going to produce a solid, and that's going to be a solid because of rule number 2. And then the last thing you have to do is balance, and actually this one happens to be balanced as it's written, so we're going to leave it alone. All right, now we need to do this final one here. Similar situation, I'm going to match things up. So if lithium is under A, right, so I'm going to have lithium, and then we have X, which is our SO4 in this case. So I've got my X way over here, so that's going to be SO4. Na is going to be a B, so I'm going to have my B, so that's Na, and my Y is iodine, so that's going to be here under that Y. All right, so now I need to go back and do the exact same thing from before. I need to check my charges and crisscross them down. So we're going to take a look at this. So that's Li, okay. So I'm going to set them up so that I have Li and iodine, and I'm going to go look at those on the periodic table. So on the periodic table, lithium is right here. It's in the first column, so it's a +1. And iodine is right here. It's in the 17th column, so it's a -1. So this is going to be a -1 and a +1. We're going to crisscross those charges down just like we did up above. And we're going to get Li1, I1. And that one works out the way that it is. The common mistake that students make here is they want to bring a 2 across after the Li, and they can't do that because we checked our charges and it doesn't work out that way. So now we're going to check our charges for sodium and sulfate. So I'm going to look and see that sodium is in the first column, so it's a +1. And I'm going to scroll to the back side and see that sulfate is a -2. Okay, so I know that sulfate is a -2, and I know that sodium is a +1. We're going to crisscross those charges down just like we've been doing for this particular problem, and we're going to end up with Na2SO4 1. So that tells me that I need to have a coefficient of 2 right there. Now the next thing we have to do is we have to identify states of matter. So we're going to start with the lithium and iodine. So again, salts of ammonium and group 1 metals, and in this case lithium is a group 1 metal, are always soluble. So that tells me that this first compound, LiI, is going to be aqueous because, again, of rule number 1. Now the next one talks about Na2SO4. So I'm going to jump over here and say that, oh, look, sodium is present. So that tells me it's always soluble as well. If you skipped all the way down and found sulfate down here, and it says they're soluble, except if they're with with calcium, strontium, barium, mercury, lead, and silver, and those also aren't present. So that means it's also soluble. So that tells me that this is going to be aqueous as well because of rule number 1 or rule number 4. So when you have an aqueous product, you have no reaction. So no reaction. You are supposed to balance this regardless. So to sort of speed this process up, I'm going to put a coefficient of 2 here and a coefficient of 2 here. And so that portion is done. Okay, so this is the video or solution guide for 13.8, 13.7, and 13.6. If you have any questions, please feel free to reach out to me, and we'll try to address those before your quiz tomorrow.